Greetings, humans. In this video, we're going to find the rate of change from a graph. Before you start your work, add your name to the title of the slides and share your slides with me as an editor. Here is the video that you are currently watching. Here are instructions on using split screen for Chromebooks so that you can watch the slides and work on your own at the same time. Our goal in this activity is to calculate the slope from a graph. We know that rate of change and slope are the same thing. To do this, we're going to use the slope formula. And this time our slope formula looks a little bit different, but we know that it is the change in outputs, which is the y values, divided by the change in the inputs, which is the x values. In other words, this is the rise of the graph divided by the run of the graph, and that is equal to slope, which we use the variable m for. Slope, rate of change, rise over run, m, they are all one and the same. Now let's talk about a graph can have positive, negative slope, it can have zero slope, it can have undefined slope. What does all of this mean? Well, if a graph has a positive slope, then the graph would move up and to the right. So if you look at this picture here, if we look to the right of our graph, the line is moving upwards. A negative slope would be moving up and to the left, meaning if we look to the left side, like in this picture, if we look to the left of our graph, we should see the graph moving up. Up and to the left would be negative, up and to the right would be positive. Zero slope would mean that there is a flat or horizontal line. If you think about a flat parking lot, that parking lot has no slope versus a hill or a very steep road would have some kind of slope. So if you look at the picture here, a horizontal line has zero slope. It is flat. And an undefined slope means that there is a vertical line. If you look at this picture on the right, if there is a line that is straight up and down, we don't actually know how to calculate that slope. We cannot calculate. There is no slope. It's not defined, meaning it doesn't really exist. It's not a value. There's no number that can describe the slope of this line. So let's do a couple examples. In this example, we're going to find the slope of the graph, and the way we're going to do that is we're going to count the rise divided by the run. And if you need to make this a little bit bigger, you can change the view settings from here. So the first thing to do is to determine if the slope is positive, negative, or other. And when I look at this line, it moves upwards to the left. So if I look at the left side of this graph, it's going upwards. That tells me that this is going to have a negative slope. Now I'm going to count the rise and count the run. So this line right here represents the rise and the run because what I did is I picked a point here and I picked a point here. So now if I count the rise between these two, I know that it would go 1, 2. So the rise here is 2, but I'm going to be very careful right now to say that because I know this is a negative slope, I'm going to write my rise as a negative 2. Now I'm going to count the run of this graph. So if I look at the point here to here, that tells me how far my graph is moving in the x direction. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the run of this graph is 10. I'm not going to write the run as a negative. I'm only going to write the rise because I know this thing should have negative slope. Step 3 says to plug the rise and the run into the slope formula. Well, the slope formula right here tells me that it is rise divided by run. So negative 2 divided by a positive 10. The last step is to simplify my equation. Well, negative 2 divided by negative 10 can be simplified, writing it as negative 1 divided by 5. Or if I wanted this as a decimal form, this would be equal to negative zero point 0.2, negative 0.20. So there is the slope of this graph. In example 2, I have a line moving up and to the right. So if a graph is moving up and to the right, then it must have a positive slope. I've selected these 2 points here and here so that I can count the rise and the run. So the rise goes up 1, 2, just like last time. And I'm going to keep this as a positive rise because I want my line to have positive slope. And now I'm going to count the run. So I'm going to start from here to here. And that goes 1, 2, 3, 4. So my change in the x values would be a run of 4. And now I'm going to plug the rise and run into the slope formula, which would be 2 divided by 4. And I know that 2 divided by 4 is the same thing as 1/2, which is equal to zero point 0.5. I've simplified it as far as I can, and now I know that my slope of this line is 1/2. In example 3, when I look at this graph, my line is moving up and towards the left. And if it's moving up and towards the left, it must have a negative slope. Now I've chosen these 2 points on the graph, and I'm going to count the rise and the run in between these two. So the rise would go from here to here, and it is 1, 2, 3, 4. I'm going to write that as negative 4 because I know that this graph has a negative slope. And now I'm going to count the run, which would go from here to here, and that is 1, 2. So my run is positive 2. Step 3 is to plug the rise and run into the slope formula. So I would do negative 4 divided by 2. And when I simplify that, negative 4 divided by 2 would become negative 2. So negative 2 is the slope of this graph. Now I want you to try example 4 on your own. Make sure you determine if it's positive or negative. Count the rise and the run by using these 2 coordinate points. Plug it into the formula and simplify. So try example 4, try example 5, and then answer these reflection questions. Once you've answered the reflection questions, you will turn these slides into Canvas and you will begin the Delta Math practice activity of finding slope from graphs. Don't forget to like, comment, and subscribe.